Yeah, for this community call, we actually have a topic. It's regarding the benchmarks. So I will do a small presentation about that topic, and after that we can talk about Memgraph specific stuff also. So this will be like a guideline topic for the call, but we can talk about a bunch of stuff later. Yeah, so maybe I can start, and then we'll get back to the Memgraph related stuff.
Yeah, since Ante is sharing his screen, you can also write all the questions in the chat, and I will read them out loud.
Yeah,
or feel free to jump in.
Yeah, so I kind of today talk about benchmarks, which I have been working on for past few months. We kind of decided to talk about this on the community call because there were several questions regarding benchmarks in the past, and just to publicly talk about this stuff so everyone can have a glimpse into what is happening and how are we viewing this topic. I think generally speaking, today I will talk about how to help you understand benchmarks and how to think about benchmarking. And it should be like a small presentation, 20 minutes max. Okay, so I guess you can see my screen, yeah. But you can see my screen.
Yeah. Super.
Cool. So just a small disclaimer, if you didn't follow the story from before, we have started doing some public benchmarks regarding Memgraph. Like the first databases that we compared to was Neo4j, since Neo4j is very compatible with us, and obviously we are very compatible with them. We support both the ballpoint protocol and support for Cypher. So the obvious choice was to compare ourselves to the Neo4j, but this will change in future. But I have this like disclaimer here just to communicate that a lot of things that I will talk about are kind of from perspective, both from Neo4j and from members perspective. So this will probably change in the future, but I will try to talk as general as possible during this presentation. Yeah, so the things that I want to talk today is the width clause, and some other stuff that is linked that you can see on the screen. I will not read everything, but the important part is like understanding what the benchmarks are, what is important to you, and how to essentially read these benchmarks in terms of your workload. So this is like the 9 steps that you're going to talk about today. And then we'll talk about understanding benchgraph that we published. And after that, we can go and talk about general Memgraph stuff. Just keep in mind that on any point, feel free to stop me and ask the question, because we kind of love this community call to be the basis for direct communication and for talk. So this really is a guiding presentation, but feel free to jump in. We can talk about anything. Okay, so not sure, did you ever heard about the width clause? Maybe a small pool in who heard about this, the width clause. Can you just write in the chat or maybe communicate? I cannot see the chat. Oh, I can.
Oh, we have our response. It's just no idea from Kai. So I think yeah, it's everybody's unfamiliar with that.
Essentially, the width clause is like it's a licensing term that is used to describe the license that you cannot use it to benchmark the database. It's very specific to the database world, and it's called the width because initially there was the Oracle CTO, I forgot his name, but somewhere in the 80s, late or the early 90s, he was very angry with some kind of research from one of the assistant professor who has the last name Davids, and they essentially introduced this clause called now famously the width clause, which kind of says that you cannot benchmark the database because the vendors don't want to like being compared or maybe wrongly configured databases and under wrong conditions and stuff like that. So this is the thing that you can actually set in your licensing. For example, it could sound like this. You can read on the slide. You may not and may not permit any third party to use licensed software for any benchmarking purposes, including running benchmarks, test or publishing benchmarks, performance or comparison test results. And essentially, if you're planning to benchmark a database, you should not just do that if it has a David's clause. So some of the databases have that. So just do your diligence and check if the database has David's clause, because this can be legally pursued, and you should definitely avoid that. So this is the first thing to consider. The second thing, when you start thinking about benchmark, is asking yourself, can every database be benchmarked identically? Obvious answer to this question is no. There are several other reasons for that. But what is important here is that you should think about for what are you trying to use the database. And this is like the guiding idea behind the whole presentation, is thinking about for what are you going to use the database. Technically speaking, you can use a lot of different databases for different purposes, like GraphQL database, and databases can be used for some kind of SQL tasks. The question is this optimal for your workloads? And is this like something that you're planning to do and something that will actually help you in your organizations? But in essence, so the databases are very simple. I mean, when I say simple, I actually kind of sarcastically mean that. They are actually not, and there is a lot of complexity behind the databases. And if you go to the DB engines, you'll see they have like 415 databases currently in ranking. And when you start comparing the databases, I think we all should strive for the fairest comparison possible out there, and kind of trying to put the apples to apples, oranges to oranges. But as I said, you can use Postgres for something, which you can use also Memgraph for something. So it's like you have a task on finding the relationship. You can use both Postgres and Memgraph for the same task. The question is, how are you going to compare these two benchmarks under the same conditions? Now, it's not just about what system are you comparing. It is essentially the most important thing is your workload that I was mentioning, and the performance stats that are usually kind of swapped with the term benchmarks should not be like done in the isolation, because there is a lot of other factors that can be important to your workload, such as tool support, scale, what type of data set you have, how dense the graph is, and stuff like that. All these things kind of play an important part. And when we say workload, we kind of assume your working environment in which your data set, your queries, your scale, your problem that customers have will essentially be used to kind of bring some value. And that is the benchmark that you essentially want to consider when you talk about the benchmark between different databases. Yeah, one important topic that I forgot to mention is that we have like this Simpsons GIFs that are related to the content, and essentially using your own workload is like living in your own home, where you kind of set up all the things that you care about and you want to bring the most out of it. So now that we kind of assume that you're running on your workloads, it is important to ask yourself what performance stats you care about. So it is not just like how much something is faster or how much something is slower, because when we talk about the marketing, it's always you need to put these simple lines and simple sentences But when we talk about engineering perspective, you have a lot of this. If this is something, then this is something, then this is something. So you have like this clauses that kind of prove some points, and it's not like it's not easy to say just one sentence. This is faster for that many times or slower and stuff like that. So there is a lot of ifs, and you should think about performance tests that you are planning to do. For example, is read performance important to me or to you? Is the write performance important to me or to you? So these things are very different, and they can be drastically different in terms of how the databases are structured, how they are organized, and kind of what performance implications each database has. One of the other examples that kind of I noticed that a lot of people misunderstood is how volatile your dataset is. So if you have a highly volatile datasets that often have a tendency to change, this can be very stressful to the databases. Reason for that is changing your data prevents the database system caches to kick in or previous query plans and stuff like that. So you need to reconsider also how volatile your dataset is, for example. One of the often question is latency versus throughput, or what do you matter most? Having like a bunch of users connected to the database and having a strong throughput in the system, or having like the lowest possible latency in which every query will return in minimal possible time. So all these things matter, but it is impossible to know what is most important for you. Kind of you have to think about this, you have to decide, and you have to kind of pick the tests that are most important to you. Because as I said in the last slide, all these things depend on the databases that are very complex, and there is a bunch of databases that can do identical tasks. For example, streaming algorithms, all these things are kind of important to some people, and it's important to evaluate these things. Yeah. But now, for example, once you kind of have your workloads, so you have your data set, you have your kind of performance set that you want to test, for example, reads or writes, then you start to think about specific metric that you want to measure. Latency being one of them. And like the standard question that could pop up is how the latency of a single query compares to latency of a 100 query, 1000 query, or 100 and 1000 queries. So this is like important because not everyone is running the same number of queries, and change in the data set, for example, having a volatile data set, can massively impact this latency queries, because writing and reading something in the same time or like interchangeably can impact this quite a lot. So now that we are talking about latency, tail latency being the example of one of the important terms in the benchmarking and measuring performance in general, tail latency essentially is hypercentric latency that represents the request response time in percentages. So when we say P95, this means that the latency you have under the P95 is essentially the latency that just 5% of the requests will have the worse latency than that, and 95% will be faster than that latency. So you're essentially looking at that outliers, these 5% of outliers that can be very, very slow. And now thinking about the tail latency, you can also think about, is this like 99% latency very important to you, or is it just 1% or 99.99, right? So thinking about this essentially will help you understand what you want to measure and what is important to you, because designing a database system for P95 or P99 is like a completely different engineering challenge from a bunch of different perspectives. But overall, there is a lot of factors that can also influence these results, as I mentioned previously, like the scale, data sets, type of queries, etc. So you should like be very careful when thinking about this latency, for example. but this goes for a bunch of other metrics. Yeah, and I kind of fast-paced through this and talked about what are the important things when you are considering your workload. And there is a hill ahead, and that is that benchmarking is hard and time-consuming. And there is a lot of like talk that all the benchmarks are lies, damn lies. They're all liars, and this is true in some part. I will explain why. But essentially, it is a time-consuming task, and as a customer of some database or like user of the database, you want to understand the performance profile of some software, and can it be used in your specific workload. And for that, the best way to test it is to use some of the tools that you have on the market that are freely available and that will like help you find or test or validate those results. So you don't have to like build everything by yourself and test everything by yourself, which is, as I said, time consuming. So the question here is, are the all benchmark liars? When we said about setting up the specific workloads, specific queries, tests, metrics, they are obviously very, very different between different customers. So we all tend to use databases on the different ways, and there is not like a single source of truth for setting up the benchmark. There are some best practices, for example, tail latency being one of them, but there is no like absolute source of truth for setting up some workloads. So in a sense, when vendors publish their benchmarks, you can kind of find a lot of useful information that just if you want to like take a closer look in what is actually happening and what is being measured. It can help you minimize your time to understand what each metric kind of means, and in general, you can speed up your process of choosing the right tool for your workload. So with that in mind, I kind of wanted to communicate that we also have pushed this Benchgraph platform for running benchmarks. As previously mentioned, currently there are Neo4j and Memgraph there. We plan to add some other databases. You will see about that in the future. But generally speaking, everything I said now is applies to this. So you want to run that benchmark on your own conditions under your workload tests and validate or debunk the results and see all these through your own lens. So taking a look into these specific details about, okay, how this write test was executed or how this read test was executed, this is like very, very important to me. So starting from what is my workload, what is my data set, what are my performance tests, and what metrics is important to me, you kind of come to your own conclusions for each benchmark. If this wasn't tested by the benchmark, this is unfortunately means that you will have to test it yourself. Or if it's not, you can maybe just fine-tune the benchmark tool that you have on your disposal to try to reiterate on the test. So we essentially published also some content regarding to this. I think we can share the presentations after on the Discord, so you have all these links, but we shared them also somewhere previously. So I will just like now go to the Benchgraph, and I will just briefly talk about the things that we did, just from the benchmark perspective, not from the results perspective, so you can understand what is important here. So for example, platform, we have two different hardware. One is based on the AMD architecture and one is the Intel architecture. And each of these architectures is like representing a different type of hardware. So this Intel being a bit older one, and this AMD being a little bit newer one. And this is also good thing to test on different hardware from that perspective. Then there is like engine conditions. So you can run the database tests on your when the database is completely cold, when you have executed a few simple queries, or when you have executed the whole workload. For example, these are some kind of conditions in which your database will run in production system. But this is just some subsample of possible conditions. And you can see kind of how these change as you change the certain number of conditions. Number of workloads also kind of represents how many concurrent threads are executing the queries. This can also be important from perspective of how strongly you're stress testing the database, what is kind of the peak throughput that you can achieve with running multi-threaded queries. And this kind of gives you the perspective of what you can expect from your database that is running on some kind of server that has a bunch of cores and that you're running like concurrent users that are constantly hitting the database. Also, if this is like not important to you, you should like not even consider this number of workers. If you just like use one CPU core and just like execute basic queries, this is like worthless in your use case. But in some use cases, this can be very, very important. Obviously, as I mentioned, there are different datasets that we have here and dataset size. So the scale also impacts the overall results. So this is something to keep in mind. And for example, the workload type is also very interesting. So you can execute the test in complete isolation where you have just simple query when you're running that query, or you can like take a bunch of read queries and take a bunch of write queries and just execute those, and you kind of have some kind of different balance between writing and reading, which can again influence results quite dramatically. Or we have like also this realistic mode where we just like run a bunch of different queries and kind of sample the result. So what I wanted to communicate is all these things matter, and you should kind of take a look for all these details behind the scene and understand them and kind of try to apply them to your data set and your workload, because this will be like best baseline for what is happening here and what can you expect from, say, as an example, Memgraph, since we all are here regarding Memgraph.
Ante, one question, if I may.
Yes.
Is there a combination of these settings where we are performing worse than Neo4j?
Yes, of course. So, for example, if you go to the interactive workload, you can see that on the cold run, so when the database is started and you start executing queries, you kind of didn't pre-warm the database at all. And there is this mode where you have a volcanic run where we have executed the whole workload. So we took like, in some cases, let's say we took 5K queries, we have executed those with some kind of arguments. Then we have took again 5,000 queries, execute again with the same arguments. And then when you pre-warm the database, you can see that Neo4j, for example, in this case, starts to perform much better. Now is the time when you kind of took your lens and kind of start what is happening here. And then you will see that Neo4j actually kind of creates these caches in the RAM for faster query execution, which brings them a lot of performance, which initially they don't have. So you kind of find out all these things by kind of taking a look into small details in understanding what is happening. So having all these data is kind of useful to you because you don't need to do this yourself, and you can kind of see what you can expect from and how the system behaves. So what is essentially Chris mentioned is the same thing with number of workers. So if you kind of increase number of threads, what happens, right? And one of the like the really bad things that Memgraph has here. So we have like the issue with query 12 in this BI workload. It is interesting that Neo4j is much faster here, but we have some kind of query planner issue. This needs to be fixed. But yeah.
That's very cool. Thank you, Ante.
Yeah, so with this, I kind of finished my presentation. If somebody have any question regarding this, we can talk on all of that points that you have seen. So is there any other questions regarding it?
One question I can ask on behalf of the audience. You have published the benchmarking tool so that people can do this on their own workloads. If they come up with an interesting result that they would like to talk about, either we're incredibly fast or there are things that could be optimized, what would you recommend they do?
Yeah, so as Chris mentioned, and as I mentioned at the end of the presentation, we have these links that lead you to these blog posts. I will just quickly share screen again. So if you kind of follow this link here, you will essentially go to the blog post that leads you how to benchmark, in this case, currently Memgraph and Neo4j, but this will change in future. Once you did that, it is always interesting for us to find out kind of where we are bad or where we are very good. And you can share that on Discord, DM us or Twitter, everything like works for us. But just bringing the awareness where we are like very good or where we are very slow, it's always useful to us. We kind of know the most of the things, but yeah, it is interesting to see how different people actually use the databases in different ways. So we have a bunch of different use cases that are completely different. And it's when we talk about production-wise, what is the most production-like environment? It's very hard to define that because the databases tend to be, as I said initially, tend to be used in a very different ways.
One thing I'll add to that is that if you do not want to share your results in public, you can also reach out to contact@memgraph.com and it will end up in the right place.
Right, yeah, right.
Yeah, I also have a question for everyone, I guess. Has everyone ever run their own like benchmarks for anything, or maybe used some benchmarking results to kind of weigh out the decisions you may have like dilemma about? No? Cool. This is the right place to learn about those, I guess.
Yeah, so we can talk about this, but generally speaking, I'm kind of curious, do you have a Memgraph related questions in any regard? It doesn't need to be about the benchmarks. So I see a bunch of different folks here. So never met with Kai, I guess. I guess the Matthew also. Not sure who Tyler is. So maybe if you can do a small intros and we can continue discussion around Memgraph and possible questions or benchmarks.
Yes, I can give a quick intro. I just came here from Discord because I saw the message. And yeah, that's kind of why I'm here. I mean, in my free time, I find the graph database is really interesting. So yeah, that's how I ended up here. But yeah, I think the like data set you shared on like the bench graph page is like really nice. I haven't looked that much into it right now, but yeah, I think it looks great. Also really nice to see that you aren't bothered to share results that aren't in your favor, because it's I think that happens very often, that you go on a website and they tell you, oh, everything's like 1,000 times faster, and then it's really not. It's just like one specific case. So I think this is really great. Yeah.
Yeah, I kind of agree with this, that we kind of showing the community where you're good and where you're not so good is always valuable to community. But on the other hand, it's, for example, very hard to talk when somebody asks you how much faster you are. So there is like there is no single sentence that you can describe it because there are so many ifs there and so many cases, and those things are not like immediately clear. But yeah, cool.
And it helps that our benchmarking is completely engineer driven, and they tend to communicate in a much more forthright manner than a marketing team.
Right, yeah.
I have one final question for you, Ante, that I'm curious about.
Yeah.
So you spend a fair amount of time building 2 versions of the benchmarking tools.
Yeah.
And lots of incredible results. Looking back at it, what would you wish you added to it that's not there yet? Just looking back at it, are you going like, oh, I wish we also did X?
Yeah, so like running the benchmark, you can track a bunch of different stuff. So you can actually track the disks hits, the kind of where the bottlenecks are. You can track a bunch of stuff. And generally speaking, tracking a bit more stuff when doing benchmark would be like one of the things. And essentially, whatever you measure, making it visual helps kind of see some kind of anomalies. And I guess in the first iteration, we kind of overlooked some anomalies that we had. And yeah, so that will be thing that I changed. So visualize everything and kind of track the almost everything you can.
Mm-hmm. That makes sense.
Yeah.
Cool. Thank you.
Just a small question for Soren. So Soren, you obviously kind of we kind of all met here. We talk on every community call. Do you have maybe any question we kind of forget to talk to these folks we kind of know?
No question as well, but it's a really interesting tool, and I really like the visual or the charts you provided, and it's amazing work you have done.
Thank you, Soren. Thank you.
Oh, maybe this is a bit of a wider question, but I'm just wondering, because I've just been browsing the dataset a bit, and I see that like for smaller datasets, you can actually run in like less than 60 megabytes of like RAM, which is I think quite impressive. But yeah, like that makes me wonder, are there like any plans to like support edge style workloads or not at all? Because like this, in terms of like resource usage, it looks to be like so efficient that would be possible in my mind.
Sorry, I just didn't catch I catch everything except the part when you talked about what type of use case or workload. What did you?
Edge like workloads, so deploying to like edge servers like I don't know, Cloudflare provides something like that.
Yeah, we have some users deploying Memgraph to these ROS devices that has like very small memory footprints. So deploying to this kind of edge IoT devices is, I guess, possible if you kind of have sufficiently enough RAM, because Memgraph, like in the baseline, have like 70 megabytes or 60 megabytes of overhead, and then just like each node and edge has like this kind of standard tags for megabytes, so you can kind of easily calculate, is this fit on your device? And obviously it needs to have some kind of Linux there because you cannot run.
Yeah, so just to clarify, the type of edge workers he meant is like Cloudflare has data centers in lots of different cities around the world where you can run small workers closer to the person that's opening your web page. So say that you're in Zagreb, there might be a data center near Zagreb, so they spin up a little Docker container that runs on the ARM CPU that has 192 cores, and then that logic is executed on that Docker container, on that ARM core, close to Zagreb. So that's the edge networking we're talking about in this scenario. Your answer is still valid because it's like, do you execute on ARM? And do you execute on low memory, which are the same characteristics you expect in edge computing, but it's not the IoT you had in mind?
Oh yeah. I think that it was related to edge IoT, not edge computing. Sorry. Yeah. But the same logic applies to both cases. Yeah. Chris, thanks for kicking in. Yeah.
Yeah, but yeah, I guess the answer is still valid. Yeah, that makes sense.
Yeah, absolutely. And one of the things that blew me away when Ante was showing off all the results is that you would expect Memgraph being an in-memory database, like we write to disk first, but all the logic happens in memory. You would expect the memory usage to be higher for Memgraph versus Neo4j, but it's actually lower in many situations, which is absolutely ridiculous and counterintuitive, but it does show that that characteristic does not limit where you can deploy it. If you've got an edge worker with 1 or 2 gigs of RAM, you can do some serious compute on that.
Yeah, that's the interesting thing that you find out when you start benchmark is the system tends to operate in a different ways, even though you expect the in-memory graph database to use the more memory, the things can be quite different due to many different reasons. JVM, for example, being the one of them. Okay, cool. So I think we can call it up.
I guess that's it. Yes, as Ante said, we will share the presentation on Discord. So I'm looking forward for you all if you're going to try the bench graphs for yourself, and then let us know your results, especially you guys, since you're already in the benchmarking world. So to hear your input and feedback.
It was a pleasure to talk today. Have a nice rest of the day and see you soon.
Yeah, enjoy.
Fantastic. Thank you for hosting, Matej and Ante. It was awesome.
Yeah, no problem.
Carry on. Bye.
Hopefully
Bye-bye.
we'll see you again.
Bye bye.
Bye-bye.
Bye.